All right. Hello, everyone. Welcome to Wednesday. Now, tomorrow is Global Champagne Day, but don't pop those corks just yet because we've got a webinar to do here, and it's important. Why? Well, because the housing industry is currently one of the least digitized sectors of our economy. Thankfully, change has started to take place, and the industry is quickly adopting enabling technologies to create efficiencies and streamline processes. And today, we have three guests who will explore pivotal questions like, what is digitization? And why is it so important to the housing industry? And how can it be applied to homes? They're going to highlight specific projects and case studies to help builders and architects understand how they can leverage innovative technologies to enhance their businesses. Now, who are these three guests, you ask? Well, we have John McLinden, who is the president and CEO of Digibilt. He has 35 years of experience in the development, commercial construction, and home building industries. He developed over 2,000 residential units with full responsibility for design and construction. And under his Streetscape brand, he pioneered the How Do You Live mass customization process. Now we also have David Hessler with us. He is the co-founder of Hessler System. He's a biologist, a computer programmer, and an entrepreneur. David has worked in biofarm development and also co-founded 3 startups, a biotechnology company, and 2 scientific software development companies. He has served as a senior software director and product portfolio manager for Biovia Dassault Systems, and served on the project management team for construction of 30 custom homes in Eco Village at Ithaca, New York. And finally, we have Ilka Cassidy, another co-founder of Hessler System. She grew up in Germany and received her diploma of engineering and architecture degree from the RWTH Aachen. Now, Ilka connected to the U.S. during her year at the University of Washington in Seattle, where she won a scholarship to study within the graduate program. Now, eventually, she moved to Philadelphia, where she co-founded C2 Architecture in 2005. She has worked on multiple projects as a certified Best House consultant and is an active member of Green Building United in Philadelphia. Before we get going today, I have to tell you about our sponsors for this program. The first is Panasonic Healthy Indoor Living Solutions. Panasonic is helping builders across the country differentiate themselves with powerful, code-compliant, and cost-effective indoor air quality solutions that provide a safer environment for homebuyers. The next is Mitsubishi Electric. Mitsubishi Electric promotes sustainable building through the electrification of residential and commercial heating and cooling products. Their mission is to advance technologies that reduce waste output, promote sustainable resource while increasing energy efficiency and eliminating dependence on fossil fuels. We also have Huber Engineered Woods. Fueled by on-the-job site analysis and building science principles, Advantech Subflooring, Zip System Building Enclosure, and Exacord Product Solutions have changed the way construction teams build quiet floors and air and watertight building enclosures. Learn about their new Exacord line of magnesium oxide panels at www.huberwood.com. And finally, Schneider Electric is driving the digital transformation of modern homes with smart and sustainable energy solutions for ultimate comfort and energy efficiency. Their connected home ecosystem of smart energy management solutions provides digital control of energy use throughout a home, from the grid via their smart electrical panel to their connected wiring devices. This grid-to-plug solution makes it significantly easier to create smart solar power and backup power ready homes, both now and in the future. Now we're going to be taking questions for our guest, and just use the questions box. It's probably on the right side of your screen. I'll review those and pose them to John, David, and Ilka during the Q&A time set aside after their presentations. Now, here to share a little more about our guest today is the former chief architect at DOE's Building Technologies office. He is now the content provider for the Housing 2.0 program. A friend to many, here is Sam Rashkin.
Thank you, Mike. Hey, welcome everyone. I want to remind all of you who come to these webinars, again, about the purpose of what we're trying to do. Housing 2.0 is kind of like drinking through a fire hose. We provide over 150 best practices, how the housing industry professionals can actually optimize the user experience in everything they do. And so we cover a lot, and almost too much to go into a lot of the good detail, I think, would really help make a lot of the recommendations we provide even more actionable. So what I'd like to do with these thought leader webinars is to abuse a lot of my friendships and bring in some great speakers to really share with you the kind of the actual practitioner view of trying to apply our recommendations. So I'm so grateful that David, Orca, and John can join us today. You know, in my work with leading the national programs, I've traveled like 80,000 miles a year. I've seen tens of thousands worth of homes in construction. And I really have come to appreciate that this industry, as Mike has said at the beginning, is probably profoundly the least digitized industry in the country. And that has to change. And I think we predict with high certainty that your future is a digital future in the housing industry. So today is a special opportunity for a deep dive into some of the best companies I've met so far in all my travels who are bringing this advanced innovation to the builders. I'm so grateful they're here. They're amazing at what they do. I've been so impressed. I hope you enjoy them as much as I have. So I'm going to hand it off to David to start things off.
Well, thanks so much, Mike and Sam and Green Builder Media for inviting us. Is there an echo? There we go. Thanks so much for inviting us. We're happy to be here, and we're always excited to talk about how we use 3D modeling to help architects and builders, realize efficient projects. And our specialization is in offsite manufacturing, so we use 3D models for offsite manufacturing. Real briefly, Hultrum Systems is a small partnership. Ilka, my brother Steve, and myself, we all bring different things to the party, but we're all unabashed building and data science geeks, and we're particularly enthusiastic about high-performance buildings. The company does mostly custom single-family and small multifamily projects that have a focus on high energy performance and high low carbon footprint buildings. So we work towards passive house standards, and we use vapor open wooden assemblies, and we focus on offsite prefabrication and panelization. In this presentation, we're going to talk a lot about the value of high fidelity 3D models and how they fit so well with prefabrication, so some offsite manufacturing, and what we do with those models, which goes a lot further than just pretty pictures. So the topic is digitization, which is often also referred to as digital twins. It's a topic very near to my heart because I've been working with digital twins across a large and very varied range of data constructs for a long time. I've worked in molecular biology and chemistry and material science and material safety and handling, simulation, physical simulation of assemblies for aeronautics and aerospace. But the issue is that underneath those things are computer models that represent, various properties and behaviors of things. So what I've noticed over the years in construction is not different than other types of R&D like biopharma or aerospace, is there are silos of information, and what it often gets in the way. So for example, in construction, there's a spreadsheet model for costs, and there's a building model for the parts for a factory, and there's a set of construction documents for working on site. And those things are often derived from different models and built in silos. And they shouldn't be. They should all be deriving from a single solid model that keeps them synchronized and represents a single point of truth. And those various perspectives of the model should all be derived from it. And that's why we're here, to show you how we do that. So briefly, you know, we focus a lot on offsite construction. We think it provides us with a high degree of leverage and our partners with a high degree of leverage. I'm not going to belabor all the ostensible benefits of offsite construction. I'm sure you're bombarded with those every day. And this slide does nothing more than remind you of all the invites you get for webinars and things. But we do believe, and our experience shows, that there are some direct benefits from offsite we've experienced ourselves. And they're not necessarily the ones you typically hear from these seminars, because since we're very much focused on building science and high performance envelopes, there are certain kinds of things that builders that are not necessarily familiar with those technologies and innovations, they can derive benefit from using offsite and pre-design in 3D modeling without actually knowing a lot about those things. And those are things like air sealing and vapor control layers, which Sam spent quite a bit of interesting time talking about. Pre-design also helps us eliminate thermal bridging, which is a specialty and discipline unto itself. And of course, there's the obvious benefit. Assembly is fast, and therefore it reduces weather risk. And we experience that in our projects all the time. So these aren't theoreticals to us. These are things that we work on all the time and we see in our own projects. So Boston Consulting Group recently published out a study they had done where they were surveying across the world offsite construction. And what's most notable about this is that if offsite construction represents 20% of total construction in other parts of the world, like Europe and Japan, we're barely 10% of that. And all those webinars that I was pointing out on the other slide are, one of the things they do is ask people the questions, well, why? What is it that you think that is preventing offsite construction from rising to meet the demand in the way it is in Europe and Japan? And of course, there are some obvious answers like capacity and access, but the top issues, interestingly, tend to be things like from builders and from architects and from engineers and, you know, different parties involved in the construction process. I actually don't know how to get started in offsite construction, or I don't have any expertise in it. And then, you know, other things like, well, but is it really proven? So let's talk about those things a little bit. We have quite a bit of experience delivering projects using offsite construction, and we do not construct stuff ourselves. We are an engineering partner. We're basically an information hub and a design intent translation into high fidelity 3D models to work with the other partners. So we sit in between the architects and the builders and the factory, and we intermediate, giving them the best information and the highest quality and highest accuracy models we can, so that everything goes right and we design out as much risk and mistake as possible. And we work with factories all the way up to huge, highly automated and roboticized factories. This one's Blueprint Robotics. It's a huge factory in Baltimore. And they do panels for us. And in fact, we engaged with them because they were not interested in doing single family projects because of the design risk around smaller projects. They would only do larger projects. But they engaged with us, and they use us as their partner for small projects, because we can essentially design out all of their risk around dealing with the project and making sure that it's ready to manufacture. And we do that through modeling. We also work with hybrid and smaller manufacturers. Here's a hybrid manufacturer in upstate New York, New Energy Works. They have some fabrication line machinery, and they also use skilled tradesmen to fill in the gaps, and they also do timber framing. So they have a lot of specialty in-house already. But we do modeling for projects with them, and we hand them, you know, essentially shop drawing ready design and specifications that makes it very low risk for them to fabricate, you know, custom home projects or small multifamily projects. And I also would like to say that another kind of project that we've been working with recently is we're trying to help builders that would like to start doing panelization internally and don't have any machinery. We have projects where we have essentially manual factories. So these are builders that have shop space and storage space, and they do off-site fabrication, which helps them deal with using their capacity in the off-season or in bad weather, and then increasing or reducing their cycle time, so speeding up the installation and assembly of their buildings once the weather turns clean. So panel assembly is really one of the primary benefits is rapid installation. You know, you take big pieces of the building and you put it in place with a crane and with a team that assembles the pieces. Obviously, it requires a high degree of accuracy from everything from the foundation to the components, and it does require some specialty training of crews, which we help with. But the point is that if you don't have a highly digitized, super accurate model, including the necessary confirmation and validation points of, say, the foundation and the site work, the assembly won't go together correctly. Inversely, and obviously, if you do have that information, the thing will go together really fast and it will go together without any mistakes. So what I can tell you is that if you have any of the typical concerns around the ability to leverage expertise in how to use offsite construction and how to use 3D modeling to make your projects more efficient and more accurate, that's what we're here for. We have expertise, we have experience, we have a process, and we can help. So our process basically works through a series of steps of constantly elaborating a more sophisticated model. We start at a feasibility level. We take design intent, which is volumetric models from an architect or a designer. We convert them into a basic parts-based model. And then we start iterating with the builder, with the factory, with the design team to ensure that, first of all, the building is buildable, and start doing feasibility pricing, which is a lot more accurate than rough estimates, but not as accurate as a fully detailed production contract. And then over time, we build a fully elaborated parts model and get a locked price from the factory, and the builder's scope is well defined, and then there's production and then assembly. And throughout that time, we're continuing to aggregate and integrate data into what we call our single integrated manufacturing model. This data is always accessible to the project team, and it's always up to date, and it represents, you know, the single point of truth for what the building is really supposed to do, and includes many features which Ilko will cover in a moment. So now I'd like to introduce my partner, Ilka Cassidy, and she will take you through some of the SIM process. Ilka?
Yeah. Thanks, David. So we get asked a lot what the SIM model is and what the difference between a SIM model and just a kind of a basic or even very detailed Revit model is that we get from architects quite a bit. And this is a Revit model that we got on one project from the architect. It's very, very detailed, and Revit in general is really, really good at conveying design intent and really communicating between the architect and the client, and also doing some kind of volumetric kind of aligning between all the different perspectives. And the David, next slide, please. And the outputs out of this model kind of looks like this, where we look at elevations, we look at window schedules, and we can even go into like 2D, more detailed drawings like window details, and communicate that pretty clearly. But then when we look at a parts-based model, that looks quite different, because all of a sudden out of this, what we do is kind of translating out of this volumetric model really, the parts that need to be fabricated in a factory. So this is kind of what that looks like. And the outputs, next slide, please. look like that. And you can see, so it's very clear a panel drawing. So once we develop this the single integrated model where we're looking at all the different parts and hangers and screws and everything that needs to be modeled, we actually divide up into panels so that it can actually be fabricated in either the factory or in a shop. And along with these panel drawings, we can also then kind of take advantage of you know, showing all the how everything goes together in terms of installation drawings and just kind of panel organization drawings. Next slide. So, and once we kind of realized what you really had to do in order to panelize a building to really make it manufacturable off-site, we realized that there's just so much potential that's typically lost, right? Because typically a manufacturer, they're just interested in what they are building. So that's basically their scope. So in order to manufacture, they built this model, but that's about it. And for us, there's just so much lost opportunities because you can just add so many more perspectives now to this model. For example, MEP. So once you actually have a MEP design modeled as well, you can actually integrate that into this parts-based model. And because the parts-based model is actually what's exactly is going to be built off-site, you can make sure that all the clash detection that you're doing in the computer now is actually going to be built like that later on. And then we realized, so it's really not just about what's arriving on site, it's also what's already being built on site that's actually receiving those panels. So everything kind of has to go together. And we found a huge value in actually modeling those parts like the concrete and all the load path members, steel, everything that just kind of holds up the building and integrate that into this holistic model. Next slide. And then, yeah, as I said, we kind of put it all together and are able to do very, very detailed clash detection. We look at all the chasing that needs to go through the floors, and we also work with truss manufacturers. So because we also integrate that into the model, we can align everything across all the disciplines. Next one. Yeah, and then okay, so yeah, so that at the end we really have this holistic, very holistic approach, and as David already said, it's a very iterative approach where we really come into the design process very early. So we work with the architects and we actually guide them towards, the goal is to go with through with panelization. So we know the factory preferences and we can already align the design really early on with factory preferences and give the architect and the builder details that we have already figured out, and they can actually plug that into their drawing set. The other thing that we really appreciate about panelization or off-site manufacturing is that kind of, we always talk about the power of specification. So if we go towards a passive house or a low carbon, low embodied carbon kind of envelope, this is a really great way to already determine what the wall assemblies are, because you're basically specifying this you know, this pre-manufactured envelope, and it's really hard for someone, or it's actually not possible to value engineer wood fiber out of it, for example. Like once you're dedicated to this approach, that's just what it is. And so I'm the side of Holzraum who looks at passive house certification, and this is a really amazing tool to have this already have this digital twin beforehand, because I can really look at all the tricky air sealing details. Typically, that's really hard to do. It's easy to just look at standard details and say, okay, this is how everything connects. But in 3D, that's quite a lot, you know, more involved than it looks in 2D. And with Passive House, once you're connecting these air layers, a lot of it is really, it comes down to sequencing. And in this approach, we can actually really give very detailed instructions on, okay, before this panel goes down, you have to put the membrane leader into place, because once the panel or once the steel beam or something, you know, is put together, there's no way of, you can just kind of do what you can to air seal afterwards, but you can't really slip another membrane in there to really connect everything. The other opportunity is the coordination on site, where we found that the builder can really benefit from the model as well. And this is a picture of someone actually sitting on the construction site and communicating with some subcontractors in, you know, showing them the whole model and really explaining why everything has to be where it needs to be. And yeah, how David already mentioned, we always try and give even more and more value to this model. And we found that we can attach so much data to it. So it actually becomes, we actually call it a visual database. And as I mentioned before, the model itself, we use it quite a bit as a communication tool early on in the design process. And we meet with the structural engineer, with the MEP, and we can really look through this model in real time and have a log available where we log all these different issues that everyone then has access to, and we can work through it.
Okay, thank you, Ilka. So I think what I can safely say about our model and our experience is that even with digitization, and because it is iterative, the upside is that you end up with a highly accurate and less mistakes in the field and less risk around fabrication and installation. The flip side of that is there is a lot of dialogue, right? We spend a lot of time communicating, logging, resolving, and then marking off issues that are not necessarily clearly communicated from early design, or show up because of material choices or because of, you know, side effects in changing the design. And that's just part of what we do. So our model is always being revised until it's locked for manufacture. And it basically becomes, for the entire team, as I've said, the single point of truth for what is to be built and what we've agreed to manufacture and install. I just wanted to point out that we think of the model as a lot more than just pretty pictures. So there are some additional side effects from having this much data and from keeping it current. So it becomes relatively easy to generate, for example, bills of material at the end, or takeoffs for doing reasonably accurate, or I should say more accurate estimation at any phase. We can extract data from the model even as we're building it up. So if we've, you know, only modeled part of the building, but it's pretty accurate, you can get a more accurate takeoff on the materials for that part. And all this data is made available. We make it web available to our clients and our partners, just so that we can improve communication and try to improve coordination. And that's it. So we, you know, we really feel like prefabrication is going to become a bigger thing in the future, and we think that it fits well with high fidelity 3D models. And we believe that 3D models are a good communication and collaboration tool. And we have a lot of experience doing this. So if you're interested, please get a hold of us. But thank you for your time. We really appreciate it.
All right, John.
Got it?
Yep, go ahead, John, you're up.
Okay. Well, just want to thank everybody for the opportunity. Green Builder Media, Sam, as always, thank you for the support. So the presentation agenda today is give you a little bit about our background. I'll give you our take on the problem statement in the industry. You've heard this before. The solution, we believe, is digital technology, as well as taking on the responsibility of product design. I want to tell you about our accidental discovery, and then we're going to pose a question to builders. So a little bit about our background. So we come from the industry. So we are not like software guys that had this idea to, revolutionize the construction industry. We built a couple thousand units. We're Chicago-based. We've done a lot of stuff here as well as on a national footprint. A couple thousand units is not a lot. However, it's enough to make a bunch of mistakes and truly get a feel for the industry. We've always believed that the home is the ultimate consumer product because it's where people play their lives out, and we think there's an opportunity to really deliver a better product to the consumer. While our customer are builders, we really look at our customer's customer, the homeowner. We also believe there's a better way to design and build homes. And we further believe that technology combined with a new category of service. There is a garbage truck outside our storefront here, so bear with the background noise. But it's not just the technology, but it's a new category of service that we think is the solution. And then in 2017, we put our development company to sleep, and we went at this full time with a team of folks that are pretty energized about the idea of changing the industry. So, huge industry that we're all part of. We believe there's three big problems to solve. The first is recognizing that builders don't build houses, their trade partners do. So as a result, highly fragmented, people in their own silos. There's little transparency and sadly, the ecosystem has limited access to data with very limited no incentives to share. There's no common language in the industry. So imagine a balance sheet or a P&L statement without GAAP accounting principles, what a mess that would be. And in this industry, there's no standards, and interests are not aligned because of the low bid win approach puts the ecosystem at odds. Problem two, the industry doesn't know what it doesn't track. It's pretty remarkable that builders don't know everything in their house and what's behind the wall. Because of the current process, they're reliant upon third-party folks like trade partners with good intentions, but as a result, the builder doesn't know what's in the house. Job readiness is a huge issue because time is not effectively, schedules are not effectively communicated, and the two biggest things we're going after is waste, which is pegged around 15%, and labor productivity amongst the worst in the world. And this is a pretty damning chart for the industries. Non-farm sector industries improved 150% over the course of 50 years. This industry is declining, and the real scary footnote, it's declining with a skilled workforce that's going away. There's not too many 22-year-old kids that are saying, gee, Dad, I want to be a plumber or carpenter, which is a fabulous trade, but it's a real macro problem on us, which I think the audience knows. And the other thing about what production builders do is it's complex. Every house is different. So this is an image of a customer we're serving in Williamsburg, Virginia. There's 75 homes. There's a few million pieces of material, there's a few million SKUs, millions of pieces of material, and you can see all the things on the bottom there. We're tracking that. That is what Digibilt is doing. So our company is Digibilt. We are just out of our 4th year and pretty excited about the progress we've made. Sam would always, if you've ever sat in a presentation with Sam, he's going to tell you to start with why. It couldn't be more in agreement. And our why is very simple. We provide a service and technology to builders to improve product design, reduce material waste, integrate the supply chain and the trades, and increase labor productivity. Another way to say that might be faster, better, cheaper. But this is what we're getting after every single day, and we're making progress against this, against our why. We built a platform. Starting with pre-construction, going through construction and post-construction. We couldn't help but brand it, so we got some snappy names down there. And the important part of what we're doing is we recognize we had to make it easy to adopt, because busy builders, people that are in this industry, the last thing they want to hear is a software solution that promises the world. So we had to make it super easy. So the service piece is critical. We do the work. So a builder would give us their home design. This is where we started. We create a digital twin down to a piece level, and our software is automated to generate a bill of materials, a schedule based on the digital model, and track labor productivity. And today, because of the topic of digitizing the industry, we're going to focus on the digital twin and the bill of materials, really the pre-construction aspect of this. So while we made what it was easy to adopt for builders, it was pretty hard to develop. So over the course of 4 years, we developed a technology that goes into the digital twin, which we're using Revit, which is the gold standard for a building information modeling tool. And we figured out a way, and we patented this, to get into that, to grab thousands of data points out of the Revit model and automatically generate a bill of materials. So it starts with, for us, it starts with creating a digital twin. And essentially, if we kind of look at, if we were software guys, we'd look at this as the source code. And I believe at this point, Mary, you're going to take this thing over to play a little video here. So as this video plays out, and you've seen all kinds of digital models over the last couple, I'm sure. But what's important about everything is modeled. We've got the plumbing system, mechanical system, electrical. We've skipped the Romex here just because it's a mess, spaghetti mess. Foundation system. And this is just illustrating to the level we take it. You'll see the straps on the tie down straps, etc. Here's the framing model. Everything within here is coordinated. So subject matter experts to coordinate all the chases, all the and this is, we get all the conflicts resolved here. We are looking at every piece of material on the interiors. We're modeling the trim, the base, the railings, kitchen in total is being modeled here. Every component, we're going to go through this house in a minute. It's going to be there's a little casita here, and it'll flash a sec where there's a herringbone pattern in the shower. Every piece of tile is modeled. Everything is modeled, which might just see, but I'll show you now. Did I get here? Look.
All right, you should be good to go there, John.
It's 1 second here. Okay, so on the left, there we go. On the left is that digital twin. The fun fact, that particular home, which happens to be in Fort Collins, has got about 18,000 pieces of material, and that doesn't count like fasteners and nails. We at the press of a button, we can produce a detailed bill of materials. So in this home, there's about just under 600 SKUs, stock keeping units. There's about 800 rows of detail. So, if you've ever done estimating longhand back in the day, you hopefully can appreciate this. This is, we couldn't be more proud of this. This is providing value to our customer base that ranges from a couple of top 10 builders to folks all over the country, from guys that are doing 50 homes to, again, top 10 builders. This bill of material becomes trusted. I mean, the goal here was a trusted bill of materials for trades, for material suppliers, for builders, for everybody in the ecosystem. Now, that was the data side of it. So we got the bill of materials, we got the digital twin, the bill of materials, but what occurred to us is we're taking these builders' plans, is why don't we take the next step, which is the ultimate step, and that is really going after product design. So we have now added that to the lineup. We are doing product design, community design. It is customer focused, which is critical. We use the term assembly engineering. It's assembly engineered by subject matter experts on our team. We have a full staff of people on the engineering side, seismic, structural, MEP, some specialty engineering as well. We're taking the design for manufacturing approach, which is used really in most other industries, to make it simple to design, beautiful, but simple to, not design, simple to manufacture, whether that's in the field or offsite. And then a really cool part of this is integrating the product design with community planning and placemaking. And I'll show you an example of that in a moment. So we're taking, the product design and figuring out how that fits within the neighborhood design. So just a quick example of product design and what we're doing here. This happens to be for a customer of ours that we couldn't be more excited to work for. That's Gene Myers at Thrive Builders. Certainly a leading guy in terms of sustainability and healthy homes. So we created a lineup of products for his project in Fort Collins. These are all single-story homes. These are 3 different for each series: patio homes. There are 3-car garages. You can see on this, the left one here, this is the same plan. It has a different exterior, and it has what Gene would call a do-more space, so a little accessory dwelling unit up front. What's kind of important about this, as we're doing the product design, we got to think through the functionality for the consumer and then the ease of construction for the builder. So there's another series called Courtyard Homes. These are rear-loaded product organized around these beautiful courtyards. And then he has a series of townhomes, which are rather unique in that they're single-story townhomes. So these babies should sell off the shelf. There's 3 different plan designs. There's 2 on the interiors. These are mirrored on the ends. And they come in 3, 4s, and 5 packs of the townhomes. 3 different styles here to give variety, but these are all assembly engineered and figured out about how to optimize the building process and taking out non-value added waste. Now I wanted to share our accidental discovery. And that was, so here's this goofy cartoon thing of me by John McManus with the Builders Daily. And he wrote this article about a month ago. And the title was How the Tiniest Details in a New Home Could Change Real Estate. And the punchline to that is the tool that we've created can help precisely measure a home's carbon impact, which, as everyone knows, this is top on mind in the industry, in the world, right? So the way this works is we have a digital twin that generates the bill of materials. We can then connect that to EPDs, which are environmental product declarations. So essentially that is, for each component in the building, like a window, for example, there will be an EPD about how much carbon emissions, embodied carbon is emitted into the atmosphere. And by doing that simple math, which is complicated because of all the parts and pieces, we can determine what the carbon footprint of a house is to a high level of accuracy. Now, once the carbon footprint is determined, so Digibilt is telling the world what the carbon footprint is. Who cares who's Digibilt? We're just these little guys. Under the Paris Climate Agreement, the ISO 14001 was selected as the standard. We have someone on our team who is certified in this area of expertise. So now we have a certified carbon footprint. What that means for the builder is, on their behalf, we can go to the carbon exchange, the open marketplace, and purchase an equal amount of carbon offsets, so that builder can now deliver a carbon neutral material home. So this is a pretty exciting thing we stumbled into. This could drive our business and really make an impact for the industry and most importantly, for the atmosphere here. So this is another quick video. I think it's about a minute and a half. Mary will take this thing over now, and this will play out, and then I've got a couple of last clicks, and we'll turn it over to Green Builder Media.
John, remember to unmute yourself.
Okay, this is the first phase of a project. It's 325 units. Gene is doing 220 of those, the 3 different products that I showed you earlier. So we're going to zoom in here. Now, we have a digital footprint of every one of these homes, and we have a digital footprint now of the entire development. So here are the townhomes in context. And by doing this, it also informed the design to figure out, hey, what looks best in what location. So 3 different styles here. In the townhomes, here are the courtyard homes, kind of these cool little compact courtyards to promote neighborly living, room-sized front porches, 3 different designs, all single-floor living, full basements in this case in Fort Collins. And then the last piece here is we're going to now drive through the neighborhood. So if you do know Gene, ask Gene about this experience, because it really helped us figure out, working with his team, what looks best where. These happen to have 3-car garages, which initially we were like, yikes, that's not going to be so great on the streetscape. But we've hit those in some ways where we created these little casitas, or that could be a garage. We put the garage doors under porches, and in some cases, those garages become living areas. Boy, this is going super fast. Now this is going to go into, kind of a real life look at that. That garage is turned into a casita. We've created a cool little courtyard here between the garage. So kind of a private courtyard and board. And then we're gonna go through this house. It is a kind of open plan kitchen living or kitchen dining living. So from front to back, you're seeing through this thing. There's some volume ceilings. And this is pretty cool because the single story plans have a walkout. So you've got this, you got the front exterior experience, you got the exterior experience, again, to promote the kind of neighborly living. And it's going to zoom around here and stop at the back of this house. And then Mary, I'll take it over in a second here. Boom. So this is the result of doing what, working with this group called Buildings Transparency, created this EC3 tool for carbon DPDs, environmental product declarations. So in this particular home, there's 1,380 metric tons of carbon. So, most folks don't have any idea what the carbon footprint of a house is. You can Google it, you can find almost zero information on that. So by creating, what the tool we had and looking at this, we believe this little house here is pretty important. The builder is Thrive, and we couldn't think of a more perfect person to talk about this as Gene Myers. Green Builder Media, this will be a vision home for Green Builder Media, so we're super excited to be working on this project with Sarah and her team. It will be the first carbon neutral material home in the United States registered by the United Nations under the strict guidelines of the Paris Climate Agreement. We think this is going to have a big impact, and it was made possible by the digital twin. Much like Ilka and David talked about earlier about the power of having a digital twin and all this information. And we will find ways to use this information going forward, working with builders, discovering things along the way. So I'm going to finish with this question for builders. So what's better, the 2D approach or the digital solution? So under the 2D approach, and I can speak to this because I was that builder building off of 2D plans for decades. So at the outset, some things are figured out and known about the product before it's built, some things. Under the digital solution approach, the project is built first digitally, and everything is assembly engineered and known. So we got all the data before we start. Next, most decisions in the 2D world are made by third parties without aligned interests and limited data. So you got trades figuring out what's behind the low bid trade, and I don't say that in a negative way, it's just the realities, figuring out what's behind the wall when that might not be the best thing, versus all decisions made by subject matter experts that have aligned interests with access to data, and all the coordination is done digitally. On the cost side, it's status quo cost, time, and risk impacts versus lower cost, reduced time, and risk. This is not the I had a dream speech. We're doing this for builders across the country, creating better product design and reducing costs and risk. And then, and Sam and I have talked a lot about product design, and it's on the 2D approach. You have an undifferentiated product for consumers versus a highly differentiated product for consumers, and it's better. So we're pretty excited about that. I mean, the thing we're most excited about is all the stuff I just explained. Ultimately, it's about delivering a better product at the best possible value to the consumer. And if we can do that, I think, do that as an industry, I think everybody's going to win. So that is the conclusion of what I had to say today. And I thank everyone so much for, their attention. Thank you.
All right, thank you to all of our guests. I really appreciate it. And for those of us, those who are attending, please send in your questions via the questions box. I see Sam has joined us again. That's great, Sam. First question I had for you was actually from Deborah, and it is to the Holzram team. She wanted to know, do you also do the structural engineering that is typically an added layer after the architectural construction drawings?
We work with the structural engineer, and again, the structural engineer is going to be part of the team fairly early on, and we incorporate everything that they do into the model, so so that all the perspectives are aligned.
All right. Real quick, this is an easy one. Sam, I see you raising your hand. I'm going to get to you in just a second because we have Paul, who's actually part of our quarterly workshop series and is also a builder. He has a question. Where do you get contact information for Digibilt? So John, can you verbally share that real quick, and then we'll make sure that it's put into the chat box, and then we'll also get it out in the post-webinar email.
You could email me at jmclinden, it's JMCLINDEN, at Digibilt, DIGIBILT.com. There is, we have digibilt.com as the website. We haven't touched that thing for 3 years, so we've made some progress since that, but best way to get a hold of me is just send me an email.
Okay, great. Thanks, John. Sam. Oh, hold on, Sam. I got you off mute now. Go ahead.
Yeah, I did want to get a chance just to put a little bow tie on this, both excellent presentations. And what we keep saying with software as a service is that hopefully today, everyone who's watching this presentation sees what I'm saying about this is not the kind of core competency and skill set you can expect any builder or architect from a builder, at least most architects, 90+% of architects to have. So the reason why we keep predicting a software as a service almost disruption is that we have to get all these benefits that David and Ilka and John are speaking to achieve the kinds of cost reductions and productivity and design improvements. They're not going to happen if we rely on this very antiquated business model. So the reason we're presenting these two presentations today is just to give people a respect for just the massive amount of skill that could never be expected to be within the individual builder. Even a large national builder, this is not what they'll have as a core competency. And so that is why this prediction that we move to software as a service aggregator as a certain future for the industry is so important. And that's why you've seen these two presentations today. And I want to say they were both just outstanding examples of what can be done. So I hope everyone appreciates why this is an outside service, and I'll leave it to all the questions to follow. And thank you both for just doing a great job.
We do have a couple other questions as well. Ulrich had a question for the Holzram team. Do you also model with SIPs?
Silke?
Well, we're pretty dedicated to the assemblies that we've been developing. As I talked about, and John too, about like embodied carbon and just kind of looking at building physics, vapor profile. We ended up with what we've been doing for the last few years, and we do really like that assembly, and we have not worked with SIPs now.
Okay. And this is a question to all of you. Do you only work with architects and builders? What if I'm a super involved, passionate homeowner?
Well, I'll answer that. No, we're working with, where our focus is on production builders and developers and multifamily developers. So we are not down at the single family home consumer level.
Yeah. We definitely are. I would say the majority of our projects are custom single family homes, and we can work at any level. We work with architects and architect firms. If you have one, we have in-house architecture expertise if you need it. And so, yeah, we definitely do single family custom stuff.
Yeah, and I would like to add that we actually, most of our projects, the owners are part of the team too. They join those meetings that we talk about. And what's nice is, since we have this visual tool, it's very easy to talk about things that maybe an owner might not be so accustomed to, like, very, very specific building I don't know, assemblies or details. So there's kind of a common ground on the screen, and it's very easy to involve everyone and actually give everyone quite a bit of control over the process too, through communication.
Very good. And want to put out a final call for questions from our audience. Oh, go ahead, David. Sorry, I didn't mean to cut you off there.
No, it's okay. I'm having a little bit of a connection issue. Just keep going, Mike.
Oh, okay. We did have another question from Deborah, and it is to the Holzram team. First, she says, very impressive. But is she correct in assuming that your system is either for homes that would have plumbing, mechanical, electrical, structural engineers, or spec builders that build more than one of the same home versus a single home of average size and budget? And I think, David, you talked to this a little bit before in your previous answer, but just wanted to make sure that her question got addressed.
Well, so there was a little bit of a breakup, but if I understood the question correctly, she's asking if we scale for replicable projects, or whether we wouldn't really address a single family project.
She's trying to figure out if it's for homes that would have a variety of engineers working on it, or if it's spec builders that build more than one of the same home, or is it a single home of average size and budget? And it sounded like from your previous answer that your system kind of applies to all of the above.
Yes, I would say it definitely does. Although I will say there's a hidden benefit, which John sort of hinted at, in the way they tend to work in projects of multiple units, which is that when you do 3D design, and especially we find for offsite manufacturing, there's a lot of economy of scale that comes into play. So when you have, like, for example, we do prototyping on some projects where a builder will say, I would like to do a project and I'd like some variety, but I want to optimize cost effectiveness for building slight variations on a theme of a building. So we will take that into account, and we will build variations that are all optimized to use the same manufacturing stream and a lot of the same component design, which obviously reduces the cost because it spreads that across a number of units. But our process works, well for single projects that are unique. We do a lot of, let's say, specialty, highly complex, elaborated custom homes. And we also work on things that are simpler as part of sort of an early feasibility and development to go to offsite for multifamily and for multiple replicable units.
Yeah, and one of our goals is actually to just make this accessible to, a lot of a broad audience. So we realized, as Sam said, not everyone can go through all the schooling and specialization in passive house or in building these digital twins and all of this. So what we found is that by creating this system and offering the service, we can actually provide a passive house to a builder who has not put all the time and effort into going through all this, experience and schooling, but the builder can still use this and build a passive house, right? So there's so many talented builders out there that can just take this approach. We provide this approach, we provide the envelope, and then, the builder can come in and finish it out.
Great. Well,
Mike, let me throw out a question, since I think we have time for one more at least. So the vision I share with a lot of the Housing 2.0 workshop attendees is that at some point there's so much economy of scale and just efficiency savings if we don't have so much different customized solutions for kitchens, bathrooms, and whole homes. And I envision that the software as service companies start to develop their own portfolio of designs that builders and possibly even home buyers can pick, and it's already there, pre-digitized. And through the mass customization capabilities, you can adapt to a preferred style of craftsman, a Western, Mediterranean, and you can also customize the kitchens to a preferred counter or preferred cabinet finish, and create a lot of diversity just with a standard portfolio of designs that the builders are picking from, or even the buyers. So can you speak to is that a feasible vision? Both of you, maybe start with you, John, and go to David and Ilka. Is that feasible, or do you think it always goes customized with each builder? John, you're muted. Can't unmute. Is he muted, Mike, by himself, or is it you?
No, he's not muted through the system, so.
Must be on his computer. So John, why don't you try to get him muted, and we'll go start with David and Ilka. What do you think about the possibility of providing a total design solution as well?
Yeah, I think that's what we're seeing. I think we're seeing a lot of interest from builders that are doing more than single family or single unit custom homes. They're already thinking in terms of how can I take advantage of pre-design to give me some variation, but reduce the design scope and therefore the engineering risk and all the knock-on effects of that. From having too much variation in my production.
Sam, I think you've been.
Yep. We'll get to you in just a second, John, but we're finally hearing your voice now. Thank you.
So anyway, I think that it's absolutely true that we're going to see an increase in componentization of buildings, and those things will, that ideally people can have the aesthetics that they want at a level that sort of, abstract away the aesthetics portion from the mechanicals and the high risk construction and the complexity of interlocking trades and systems, and build more components with a rapid install, but from a library of pieces that allows people to feel like there's still some custom, there's still some personality in it. It's not just completely cookie cutter. But I wouldn't throw away the idea that there's some value to standardization, definitely.
Great. Johnny, you,
For me,
There we go. I think we've got him. It's just a little bit of lag going on right now.
try John one more time. He can digitize the building and community, but he can't get his computer to sync his voice.
I love technology.
Oh, you got to love it. You gotta love it. Oh.
I'll let Ilka take some of this if she's got anything to add on to what David was saying.
That's all I got.
Oh, I can fill in. Well, I mean, I totally agree with what David just said, but I also, I guess, have to say that we work with a lot of, very, projects that are very architectural, one-offs. So the owners typically are very interested. So they pick an architect and they they kind of develop their design, and they are willing, they're owners that are very dedicated to passive house, low embodied carbon buildings, but those owners are also the ones that would like to have a say in how their bathroom or everything is laid out. So I think it's probably it's two different approaches, but I think that one definitely informs the other, and that's what we've been finding by developing these complicated buildings. We're just learning so much that we always say that every single thing we learn by doing this complicated, we can make the next building that's not as complicated a lot more efficient. So.
All right. Well, I thank you all very much for sharing your insights with us today. We really do appreciate it, and thank you to our audience for attending. And once again, got to thank our sponsors: Panasonic Healthy Indoor Living Solutions, Mitsubishi Electric, Huber Engineered Woods, and Schneider Electric. Now, if you like what you heard today and you really enjoyed the insight and knowledge, well, you can actually get this and more in the Housing 2.0 program. Now, for more information and to register for the upcoming Q4 workshop series, please go to www.greenbuildermedia.com/housing2.0 or 0, I guess 0 is. And I'll put it in the chat for everybody so they can check out that link there. And there it goes. All right. We're going to be right back here again in 2 weeks. Mark your calendars for Wednesday, November the 3rd at 2 p.m. Eastern Time, as we're going to look into the future with Sarah Gutterman. She's going to peek into her crystal ball to see what 2022 has in store. And from the sounds of it, the forecast is calling for net zero. So until next time, have a safe and happy Halloween. Stay healthy and take care, everyone. So long.